So welcome back, Earth Space Scientists. Continuing on with our Level 1 Earth Space Science internals. Today, looking at how the sun affects our Earth's climate, weather, and also the ocean currents. Okay, so previously we've learned that the sun is basically a star in the Milky Way, and it's important for our planet. And we'll see today that it drives our weather, our ocean current, and as we've seen previously, our seasons, which generally affects our climate in general. And next lesson, we'll look and focus on how plants get energy from the sun and use this for photosynthesis, which is critical for life on Earth. And that means without the sun, there'd be no life here. So in terms of the water cycle and oceans, basically the energy for the water cycle comes from the sun. Okay, so basically the sun's energy hits the oceans, and that evaporates water from our oceans and lifts it up to form rain clouds, and those rain clouds then move and they hit land masses, they fall, and we end up getting rivers, and the rivers go back to the ocean. So the cycle begins. So in terms of plants, plants also need water for photosynthesis and life, but water can be released from plants through the process of transpiration, which then pushes it again back up into the atmosphere where it can join the water cycle. Okay, so it's basically the water cycle, and the sun's energy that drives the water cycle is needed to distribute water around the globe. So in terms of wind patterns, basically the ocean is the biggest storer of heat energy. Okay, and as we've seen in the last slide, this basically drives the circulation of water and energy in the atmosphere, and also creates cloud cover, which again leads to rain. Okay, so the ocean also stores a large amount of carbon dioxide, and that's great for stopping global warming. And also about the top 3 meters of the ocean hold the most of the heat energy actually in the atmosphere compared to the atmosphere. Okay, so 3 meters of ocean water contains as much heat energy as the entire atmosphere. Extraordinary. Okay, and again, evaporation is the process in which that heat energy is released back into the atmosphere. Okay, so because the oceans are constantly evaporating, it maintains the global temperature and also the humidity around the surrounding areas. Okay, so allows also the trade winds, which we'll look at next in terms of ocean circulation. So basically the oceans act as sort of a conveyor belt which brings nutrients up from the bottom of the ocean, and also pushes water from the colder poles, from the equator, the warm part, down to the poles. So that means that the equator doesn't get too hot and the north and south poles don't get too cold. So it keeps the temperature reasonably even over the entire planet, so we can have life on Earth and make it more hospitable. Okay, and also this continuous flow also drives the trade winds, and it's also based around temperature differences and also the amount of salt, for example, in oceans. And it's also related carefully to the tides, which we'll look at later in the unit, and also the Earth's rotation, because when it's hot in the summer, that's going to warm up the water on one side of the hemisphere, which again drives the energy through convection currents for the lower hemisphere. So again, pushes the water around. So finally, the Earth also has a magnetic field, and sometimes the sun, well actually it probably always does, but the sun ejects high-speed particles, plasma, in the form of protons and electrons. This is known as a solar wind. Okay, and if the solar wind is quite large, if there's a mass ejection of these particles, then it interacts with the magnetic field, and you get pretty pictures like this, which comes from Island Bay in Wellington. That's the aurora australis. Okay, so that's going to be the southern lights. Okay, and you've also got the northern lights around Lapland, and the interaction with the particles which have been ejected from the sun with the magnetic field create these very pretty colours. Okay, unfortunately also, even though it gets slightly protected by the magnetic field of the Earth, these solar winds can also cause havoc because they're high-speed particles. They can disrupt radio communication, navigation systems, power grids and satellites, so they do cause problems for us on Earth as well.